In this episode, I'm going to talk about the process principle of material jetting. Material jetting is another process that's interesting because we're coming back to the same materials, UV curable resin, but deposited in a different way. So material jetting is defined as an additive manufacturing process in which droplets of built material are selectively deposited. So that's the closest to a 2D inkjet that we're knowing. Common names that are used for material jetting are drop-on-demand, DOD, PolyJet was coined by Stratasys, Objet, also Stratasys, originally was a different company and was acquired by Stratasys, and Multijet from 3D Systems, and there are others out there. If we look at the schematic of the process, this looks quite similar to material extrusion that we have seen in a video before, but there are distinct differences. Again, we have a build platform that moves down, we have the build part, and we have a part support structure, and we have this print head. But instead of it being heated and a bead of thermoplastic is being deposited, here we have a real inkjet print head that deposits droplets. And these droplets of material come from containers with the liquid for build material and support material, and they're fed through these tubes into the inkjet printhead, and individual droplets are deposited. I have a video for you to look at. We see the part that we have seen a couple of times, and what you see is light. So that's important. We already know it's a UV curable resin, so we expect there to be some kind of UV curing and light source. It goes over the part, so each movement is actually creating a layer, and the build platform is moving down in between. And you see it's relatively big because we have all these array of nozzles that deposit the droplets. Some examples of the parts, 3D parts, how they're positioned on the build platform, and the individual slices of that part. Now we're moving into the machine and we're taking a look. Here you already see different cartridges and you see the colored point on it. That gives you an indication that we're talking about a full color print method here. So you see that the printhead is going past the build platform. And here now I see a schematic of droplets being deposited out of arrays of nozzles. So a lot of droplets at the same time as we're moving, and different colors obviously can be mixed here. And then as we're moving and depositing the droplets in the same movement, the UV light also turns on and cures the part. So we see layer upon layer, how it's built. It's really rapid because we have the many droplets being deposited at the same time, and now it's being removed. You see the support material is washed off, so it's also a soluble support, but it can be a breakaway support. And now some post-processing is happening, some cleaning, and you see what a nice smooth surface is it. And you can also already see that the part doesn't have to be painted, it can be printed in color. Together with binder jetting, material jetting is the only process that can print in color. So, and you can already see that from a couple of parts that I brought here. Let's look at the material. We have another UV curable resin process, but we can mix that resin with color pigments. Again, we have these photopolymers that are highly cross-linked networked polymers. And the advantage of jetting is that each droplet can be a different base resin, from rubber-like, soft touch feeling to rigid. And I have an example here for you. This part, it's a demo part from 3D Systems that includes a different material feel in one part because the droplets were created out of a mixture of different materials. So you can see here, and I'm not just being difficult, you can see that I can hardly move this, and the closer I get here, I can totally move it. And here it's just flappy, so it's rubber-like, and here it's rigid. Also can move, so we had support material that was removed afterwards. So you get this soft and rigid. You can also just get that in in one part and use one material, but you can get it combined. Then each droplet can be mixed from cyan, magenta, yellow, black, and white to achieve the variation in gradients and color unique to this technology. It's important to notice the more color you put in, the more rigid it is. And you see an example here from Stratasys of this little toy that you can flip. And what I did here, I asked specifically for a part where the support wasn't removed that perfectly. So you can see it's in between. It could be easily washed off, but I asked them to leave that in here. So this is full color. And each droplet can also be mixed from different base resin to create haptic properties or digital materials. That's really what I was referring to here, that we can create gradients of rigidity or flexibility. And this was termed digital material. The jetted resin droplets need to keep its shape during and after deposition. So it can't just run, it can't splash, it can have small droplets going off. And it has to start curing immediately once exposed to UV light, because we want this to be a very rapid process. You've seen how fast the printhead is moving back and forth. Mostly used resin in material jetting is acrylate. There's always developments going on. And I wanted to point out that material jetting can also be done with wax. That's a different variation of it, but you could build up a part just with droplets of wax instead of the resin, and then you can use that for lost core investment casting. For jewelry and dental labs actually use that quite a bit.